bomb is a weapon designed to project force. For most of aviation history, the primary means of delivering this force from the air was the gravity bomb, sometimes called a dumb bomb. This term is slightly misleading. Its function is not foolish, but rather elegantly simple. It relies on one of the most fundamental forces in the universe, gravity. When a pilot releases this type of weapon from an aircraft, its journey to the ground is an unchangeable contract with physics. The bomb follows a ballistic trajectory, a predictable arc determined by the aircraft's speed, its altitude, and the direction it was flying at the moment of release. There are no second chances or mid-course corrections. The operation of a gravity bomb is a testament to the skill required of pilots in earlier eras of aerial warfare. The entire process is a complex calculation of variables. Wind speed, wind direction can push the weapon off its intended course. Air density affects its rate of descent. Air density changes with altitude and with temperature. The pilot must account for all these factors before ever pressing the release button. The aircraft itself becomes the primary aiming system. To hit a specific target, the pilot had to fly a very precise path, often descending into the range of enemy anti-aircraft fire to improve the chances of a successful strike. The bomb itself is passive. Is the passenger on a one-way trip dictated by external forces. Imagine a mission to destroy a specific factory building. A squadron would drop dozens or even hundreds in a concentrated pattern. This was called carpet bombing. Collateral damage was an expected consequence of the technology's inherent lack of precision. The weapon was simple, but its application was often brutally indiscriminate. The advent of the smart bomb, more formally known as a precision-guided munition, represented a revolutionary shift in military technology. This was not merely an improvement on an old design. It was a fundamental change in the concept of aerial bombardment. A smart bomb is a weapon with a brain. It contains a guidance and control system that allows it to actively steer itself toward a target after release. This ability to adjust its trajectory in mid-flight is what separates it from its unguided predecessor. It transforms the bomb from a passive object falling through the sky into an active participant in its own delivery process. There are several methods a smart bomb can use to find its target. One of the most common is laser guidance. A person on the ground or in another aircraft uses a laser designator to paint the target. The seeker in the nose detects the reflected laser energy. Small fins make minute adjustments, keeping it locked onto that laser spot until impact. Another popular method is GPS guidance. The bomb is pre-programmed with exact coordinates and uses satellite signals to navigate itself to that precise point on Earth. Consider a mission to disable a single communications tower in a dense urban area. Instead of a large formation, a single aircraft can fly high and far from the city. The pilot releases a GPS-guided bomb. As it falls, its guidance receives multiple satellite signals, comparing current position to target thousands of times per second as fins adjust for wind. It arrives at the exact coordinates of the tower and nothing else. When placed side by side, the differences become stark, particularly in the critical area of accuracy, cost, and safety. The most significant distinction is accuracy. A gravity bomb's accuracy is measured in hundreds or even thousands of feet. Its landing point is a matter of probability. In contrast, a modern smart bomb's accuracy is often measured in single digits of feet. That's the difference between aiming for a city block and a specific window within it. This leap in precision means planners can target specific assets, a single tank, a command bunker, a bridge support. On a per unit basis, gravity bombs are exceptionally cheap, a little more than steel, explosives, and a fuse. A smart bomb of the same weight with GPS kit and fins can cost tens of thousands or more. For missions where precision isn't primary, like attacking a large isolated base, gravity bombs remain cost-effective, but include delivery costs and risk. Inaccuracy may require multiple aircraft and bombs, increasing fuel, flight hours, and danger. One aircraft with 1 or 2 smart bombs can often accomplish the same objective on the first try. From a safety perspective, smart bombs reduce collateral damage, provided the intelligence is accurate, and allow releases from beyond many defenses at higher, safer altitudes. Ultimately, gravity bomb pros: low cost, simplicity, availability. Cons: profound inaccuracy, high collateral risk, and danger to the launch aircraft. Smart bomb pros: incredible precision, increased aircrew safety, minimized unintended damage. Cons: high unit cost and reliance on complex tech that can be jammed or malfunction. The choice isn't which is better, but which is appropriate for the mission. The decision to use a gravity bomb or a smart bomb in a modern military operation is a complex cost-benefit analysis. It is a choice dictated by the nature of the target, the rules of engagement, and the strategic goals of the mission. For a precise strike against a high-value target located near a protected site like a hospital or school, a smart bomb is the only responsible option. The imperative to avoid civilian casualties and unwanted destruction makes the high cost of the PGM a necessary expense, a legal and ethical requirement. Conversely, if a target is large, dispersed, and low value, such as a troop concentration in an open field or a sprawling, empty logistics depot, expensive smart bombs may be inefficient. Commanders might accept lower accuracy from gravity bombs given the nature of the target area. Lower cost allows a greater volume of fire where precision isn't primary. The choice is pragmatic: weigh munition cost against target value and characteristics. The evolution from gravity to smart bombs shifted warfare from attrition and area destruction to decapitation, surgical strikes, placing a greater burden on intelligence gathering. A smart bomb's effectiveness depends on targeting data quality. A precise weapon to wrong coordinates is useless and catastrophic. Gravity bombs: simple, cheap, imprecise. Smart bombs: complex, costly, precise. Selection is critical. Balancing tactical needs, strategic aims, financial realities, and ethical implications. In the end, it really depends on the mission.